So for lesson 4-9, we are only concentrating on a couple of things within this lesson. So when I X things out, it just means we're going to talk about it later. We're just not going to talk about it right now. So the equality property for complex numbers. So if two complex numbers are equal, then the real parts are equal and the pure imaginary parts are equal. So in other words, if you have a complex number equals a complex number, logic reasoning states that these real parts must be equal to each other and these imaginary parts must be equal to each other. So I can just set the A equal to the C and the B equal to the D. We are going to look at the product property of complex numbers. So this is the conjugates being multiplied. And so when you FOIL this, you actually get a squared plus b squared. Normally we get a squared minus b squared, but because negative b squared I squared, that I squared changes the negative b squared to a positive b squared. We are not going to worry about the fundamental theorem of algebra right now. We're not going to worry about the multiplicative inverse of the complex numbers or the sum and products of the roots. So we will look at, and we did this a little bit, we're going to look at some imaginary solutions. So I'm going to do example 1, and I'm going to let you do example 2 on your own. So starting with example 1, we could, well, let's go ahead and try to factor. So let's go ahead and factor. So there is a GCF of 5. So if I factor the 5 out, I get x squared plus 4. Now because this GCF does not have a variable in it, I can actually divide it off on both sides and get rid of it. If it has a variable in it, you cannot do this. So that goes away, and I get x squared plus 4 equals 0. So unfortunately, we cannot factor the sum of two perfect squares, so instead, we are going to subtract the 4 from both sides, and we get x squared is equal to negative 4. When I go to solve for x squared, I'm going to take the square root, but on the other side, I have to remember to do plus minus square root. The square root of x squared is x, and the square root of negative 4 is 2i, but we have to put that plus minus in there, so we get a positive 2i and a negative 2i. So then you try number 2 on your own, pause the video, and go for it. Okay, so the first thing you're going to want to do is subtract 15, and you get x squared is equal to negative 15 when you take the square root of both sides. Don't forget the plus minus. The square root of x squared is x. I can't take the square root of 15, but I can take the square root of negative 1 out, so I get plus or minus I radical 15. So then let's go to the next page, and on the next page, we're going to look at what looks like it's complicated, but it's really not. We have one complex number equal to another complex number. This is the real part of this complex number because there's no I associated with it, whereas this is the imaginary part. On this side, this is the real part. There's no I. On this side, that's the imaginary part. So if these two complex numbers are equal, per that equality property of complex numbers, we can set the real parts equal to each other, and we can set the imaginary parts equal to each other. So I'm going to set those two equal. 3x is going to equal negative 18. And then I'm going to set these parts equal to each other. So I have 5yi is equal to 20i. So on the left, to solve for x, I can divide by 3, and I get x is equal to negative 6. So that's one solution. And then on the right, I'm trying to solve for y. So to undo that, I want to divide by 5i, and over here divide by 5i. So the 5's and i's cancel, and I get y equals 20 divided by 5 is 4, and the i's cancel. So y is equal to 4. So you go ahead and try B on your own. Pause the video. Okay, so then with B, you should have put together the 16 and the 8x. So negative 16 is equal to 8x. And then we'll set those equal to each other. Negative 3i is equal to yi. So to solve, I'm going to divide by 8. And I get x is equal to negative 2. And over here, I'm solving for y, so I'm dividing by I. And the i's here cancel. And so I get y is equal to negative 3. Easy. Now, C, a little bit trickier, to say the least. So here's the problem with C. So you could try to distribute your x, but you also have a negative here. So technically you have a negative x in front, which you could try to distribute, but that's going to end up messing things up. So rather than have to go through a wrong answer, which seems like it should be the right direction, I'm going to steer you in the correct direction. So if I'm solving for x, because that's really my only unknown here, I want to get all of my terms with x on one side of the equation together. So because my x is here, I don't want to distribute it because I'd have to undistribute it to try to get it by itself. So I'm just going to view this as one whole term. So I'm going to move everything over, all the x's over here, and I'm going to put the non-x's over here. So I want to move this big whopping x term by adding its opposite to both sides. So I'm going to add it over here. So these are going to cancel there just like that. Now there is no, this is a whole term. There's no like term over here like this. So these are my two x terms. And then these are my non-x terms. So I need to move these non-x terms over here. So to move the non-x terms, to move the 3, I'm going to subtract 3. And then so I'm going to subtract 3. And then to move the negative 5i, I'm going to add 5i. And I can actually add the 5i here to the 3i. So these are going to cancel here, and I am left with a 1 minus I times x plus 2ix equals 3i and 5i gives me 8i. Actually, I'm going to write that second because I want my imaginary second. So instead, I'm going to put the negative 3 first. So the negative 3 is coming first, and then I'm going to put my 5i and 3i. So plus 8i. Now, I got all my x's on one side and all the other terms on the other side. So if I'm solving for x, I need to pull this x out of these two terms. So this is one whole term and this is another term. They actually have an x in common. If I factor that x out in front of parentheses, you are going to see that these x's cancel, and I'm left with 1 minus I. There's no need for parentheses since there's nothing in front of it. And then these x's cancel, and so I have plus 2i. Then inside here are like terms. So these two terms can combine. So I end up with x times 1 plus I, because negative I and 2i give you 1 plus I, equals negative 3 plus 8i. Then to solve for x, all I have to do is divide by 1 plus I. So divide by 1 plus I. So those cancel, and I get x equals. So here's the problem. I cannot have an I in the denominator because that's the square root of -1. So I have to get rid of that by multiplying by the conjugate. So the conjugate is 1 minus I. What I do to the bottom, I must do to the top, my numerator. And so here we go. So -3 times 1 is -3. -3 times -I is positive 3I. Then we're going to distribute the 8I. 8I times 1 is 8I. And then 8I times -I is a negative 8I squared. We'll deal with that in a moment. Over. Then we're going to distribute here. 1 times 1 is 1. 1 times -I is -I. Distribute the I. I times 1 is I. So those are going to cancel. And then I times -I is negative I squared. So these are going to cancel. The negative 8I squared in the numerator changes to a positive 8 because remember that I squared is equal to -1. -1 times -8 is positive 8. So same thing happens here. -1 times a negative gives you a positive 1. So this changes to +1. And so let me give myself some more room here. Whoops, try this. Okay, so now the -3 and the positive 8 combine to give me 5. So this is x equals. And then the 3I and the 8I gives you 11I. Then in the denominator, we've got 1 plus 1, which is 2. Now we've got to break that apart into its real part and its imaginary part. So our final answer is x equals 5 over 2 plus 11 over 2I. That was a doozy, but there you go. All right, so then the next section that we're going to look at is finding imaginary solutions. So personally, you can use whatever method you want to, completing the square, quadratic formula, factoring, whatever works best for you. But when you're told not to use it, you don't have to use a specific thing. I personally will always use the quadratic formula 9 times out of 10. So I'm going to do 4 and leave you to do 5, and then we will almost be finished with this section. So I'm going to list out, I have 0 on one side and everything on the other, so I'm going to list out my A, B, and C. So A is 3, B is -1, and C is 2. So if you recall, the formula is x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so that's what I'm going to sub in for. So b is -1 and it goes here and here. A is 3 and it goes here and here, and C is 2. So you're just crunching numbers at this point. So x equals, the opposite of -1 is 1, plus or minus the square root. -1 squared is 1. -4 times 3 is -12 times 2 is -24 all over 6. So then x equals 1 plus or minus the square root of -23 all over 6. And so we can simplify the square root of -23 by bringing the negative out as an I. And so our final answer, x equals 1 plus or minus I radical 23 over 6. When we're using the quadratic formula, I am okay with you having the answer like this rather than try to split it into its real and imaginary parts, but you could. So you try number 5 on your own and then check your solution. So A is equal to 1, B is equal to -4, and C is equal to 5. So plugging in the formula, I'm not going to write it again. So B is -4, goes here and here. A is 1, and it goes in those places, and C is 5. So then X equals, the opposite of -4 is 4, plus or minus the square root, -4 squared is +16. -4 times 1 times 5 is -20, all over 2. So X is equal to 4 plus or minus the square root of -4 all over 2. X is equal to 4 plus or minus the square root of -4 is 2i all over 2. I can actually perform this math, so if I split it into its real, because it reduces its real and imaginary parts, it reduces to 2 plus or minus I. So if you can reduce, you must. Okay, so let's look at the third page. So on the third page, we are not going to do multiplicative inverses or sum and products. So we're skipping that section, but we are going to talk about number 8, finding the quadratic equation for the pair of roots. So the actual problems are on my next slide, so I'm going to go ahead and move to that slide, and that's our last slide. Okay, so let me make this bigger. So 100% of the time, when you have an imaginary root, they always come in pairs, conjugate pairs. So if I told you that one of the roots was -5i, there has to be another root that's its conjugate of 5i. Always they come in pairs, never do they not. So right now we're just dealing with a quadratic. We're going to move into polynomials where we have roots or solutions where there's 3, 4, 5, 6 of them. Now we only have 2 because these are the places that it crosses the x-axis. Well, technically an imaginary number doesn't cross the x-axis, but I digress. All right, so before I do this problem, I just want to run you through, I'm just going to put off here to the side a normal solution to a quadratic, and then we're going to actually work backwards because our job is to write the quadratic equation. So let's say I start with this, x squared plus 4x plus 3 equals 0. That factors into x plus 1, x plus 3 equals 0. And then you would set each of these equal to 0 and solve for x. Right? So we're just going to go backwards. I'm giving you the roots. You're going to set them equal to 0, or set them equal to x. Then you're going to set those equal to 0. Then you're going to multiply them together, and you're going to get your quadratic. So that's all we're doing here. We're going to take each one of these and set them equal to x. So x equals -5i. X equals +5i. And then we're going to set each of those equal to 0. So to do that, I'm going to have to add 5i to this side and subtract 5i to both sides. So we get x plus 5i equals 0, and x minus 5i equals 0. Then you're going to multiply them together. So x times x is x squared. X times -5i is -5ix. 5i times x is +5ix. And then +5i times -5i is -25i squared equals 0. Remember, the I squared is -1, so it changes the sign, and this becomes a +25. and these are going to cancel. And so we end up with x squared plus 25 equals 0, and then you're going to replace 0 with y. So x squared plus 25 is equal to y, and that is your solution. So now I want you to try that on B. So it's just a little trickier, but because it has two terms, but you can go ahead, you got this. So pause the video and then find your solution. Okay, so I'm going to start with setting these equal to x. So x equals 2 plus I, x equals 2 minus I. So then you are going to subtract or add. You're going to do the opposite of these on the other side. So the opposite of these on the other side. So you get x minus the 2 minus the I equals 0. X minus the 2 plus the I equals 0. Now multiply them together. So you're going to have a triple distribution. X times x is x squared. X times negative 2 is negative 2x. X times I is positive xi or ix, it doesn't matter which. Then distribute the negative 2. Negative 2 times x, and I'm going to line up like terms, is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times I is negative 2i. Finally, distribute the negative I. Negative I times x is negative xi. Negative I times negative 2 is positive 2i. Negative I times positive I is negative I squared. Then these cancel, this becomes a plus 1, and you end up with x squared minus 4x, and then this 4 and this 1 gives you plus 5 equals 0. Replace 0 with y, and you're done. So do your homework. Good luck.